That's the hardest part of any technology, is moving from small scale to large scale. Where we're doing is a one of a kind, first of its kind. So you don't know what you don't know until you've done it. It's all about a trial and error, and you can't pre-do it because, your brute force will fix anything in small scale.
The Rational View is a weekly series hosted by me, Dr. Alan Scott, providing a rational, evidence-based perspective on important societal issues.
Produced by Soapbox Media.
The world needs evidence-based public policy now more than ever. Making the right decisions should not be partisan politics. Please help spread The Rational View by going to patron.podbean.com/The Rational View. Together, we can make a better future.
Hello and welcome to another episode of The Rational View. I'm your host, Dr. Al Scott. In this episode, I'm digging into a growing industrial segment that mines waste for precious metals. Often discarded systems can contain higher precious metal fractions than the original ore that they're mined from. Discarded computers, electronics, and in this case, catalytic converters can be recycled, and their resources can then mitigate new mining operations and their environmental impact. I'm going to explore with a proponent of this exactly what they do and whether it makes sense. I hope you enjoy it. If you do, please hit like on your podcast app, and I'd love to hear from you on my Facebook group. Don Weatherbee, CEO of Regenx Tech, is a visionary in the clean tech sector, driving innovation in sustainable precious metal recovery. Under his leadership, Regenx Tech has transitioned from pilot projects to full-scale operations, including the opening of the flagship facility in Greeneville, Texas, or Greeneville. Is that Greeneville, Don?
It's Greeneville, Tennessee.
Tennessee, sorry. Right. Greeneville, Tennessee. Don's collaborative approach and strategic partnerships, such as with Davis Recycling, have propelled Regenx as a leader in environmentally friendly extraction of platinum and palladium. A passionate advocate for the circular economy, Don champions recycling innovation and sustainable practices in the mining industry. His work exemplifies a commitment to reducing environmental impact, advancing industry ESG standards, and shaping a greener future. Don, welcome to The Rational View.
Thank you. Excited to be here.
So could you tell me a little bit about the background of Regenx? How long has it been a company, and kind of what drove you to choose this particular niche of recycling? You recycle diesel catalytic converters, is that correct?
That's correct, yes. So Regenx actually has a fairly long history. Historically, it was your traditional junior miner. And so went out, found properties, explored them, looked to develop traditional mining, and had some properties in Spain. When I started with the company back in 2015, we were just on the cusp of a change. And we had sold the property, and we were looking, so what do we do with that investment? And the concept was, the traditional poke the hole in the ground model wasn't very attractive. A little bit different, and came across an opportunity to get into material processing. And so in the beginning, it was a processing technology to look at old tailings of gold mines and to reprocess those tailings to get gold that was uneconomic back when the tailings were created, but now would be economic to process through. Wow. And like anything, whenever you start in a new area, things start to morph and things come out of the woodwork. And so we were approached by a group to say, could you work in e-waste? And so we started down an e-waste factor.
So this is electronic waste, like computers or electronics or just discarded stuff?
Mainly the chips and that. But we worked in that, and there's a lot of challenges with e-waste in how variable it is. And as we were working with that and finding some of the issues, another group, Davis Recycling, came to us and said, there's this opportunity in catalytic converters. Does your technology work for that? So at the beginning of 2020, we started doing lab testing to see how it could. And why there's this opportunity is basically there are two types of catalytic converters. On the simplistic way, there are ones built for your gasoline engines that the honeycomb that's used in it is really a ceramic. Then there is the ones for diesel engines. And the honeycomb in those ones are mainly silicon carbide. And diesel engines run at higher temperatures. So they use the silicon carbide because it's more robust.
So just to fill in people that might not be aware, a catalytic converter is a part of an exhaust system on a vehicle, and the exhaust passes through the catalytic converter, and it's got some sort of a honeycomb in there that has a catalyst that breaks down the exhaust products into something less polluting on the outlet. Is that correct?
That's a perfect explanation for it. And what that coating is usually is platinum or palladium, the precious metals of platinum and palladium.
So you've got this, all of the vehicles are by law required to have these precious metal holders in their vehicles, and they're just usually thrown out. Is that the case?
Yeah. So what there is there is a recycling network, but it's more focused in on the gasoline because the recycling is done through smelting. So throwing these catalytic converter honeycombs into large blast furnaces to melt it down.
Ceramic, basically.
Yeah.
You're melting ceramic?
Melting the ceramic.
Oh my gosh, that's hot.
That's very hot. But it's not hot enough for the diesels, which are silicon carbide, which require a whole other level of energy. So for a long period of time, most of the smelters were rejecting silicon carbide because of their process. So that's why Davis came to us and said, there's this market. Can you do something? Because just melting isn't a sustainable source of recycling. So we're coming at it from a chemical side, hydrometallurgical. So fancy word for leaching.
Right.
We put the materials into a leach bath, chemical bath, that will separate out the platinum and palladium off of the silicon carbide material.
So this is like an acid kind of chemical bath?
Yeah. In the simplistic basis for it. There's a few other pieces to make up the special sauce.
So you put the catalytic converters in it and you get this out. So is this economical? Like, how does this compare to just like mining new stuff? Like, you're a miner here and you're doing recycling. How does this compare to like a normal mining operation in terms of profitability or quality?
Well, ore quality, it's a lot higher. We're dealing with a lot more. The grades that we're dealing with are much higher than anything you'd get out of the mine.
Wow.
And it all depends on where your life cycle of mine is. We're cheaper on a holistic view and even on a baseline because the amount of dirt you have to move to get the small amount of ore for any of these operations is massive. So there's a lot of costs up front to get into producing. But a lot of pieces also on the environmental side, we produce 99% less CO2 and we produce 95% less water, usage of water type thing. And our operations, we can be set up in a warehouse facility. So
wow,
the transportation issue is also reduced.
So there's higher grade ore, so you're producing less waste per unit of output precious metal, I assume. Yeah,
and even with that, we're moving towards a zero waste model because that silicon carbide I'm talking about is highly valuable in itself. They also become one of the critical materials list because silicon carbide is becoming a much more desired piece of the economy, especially in supercomputing, AI computing, all those types. The again, the same thing that happened with the engines needing a more robust heat resistant is the same thing happening in computer chips. With all these extra processing speeds and that, they run at higher temperatures. Mm-hmm. So just putting them on the normal chip backings aren't working. So it's becoming more and more requirement for silicon carbide. So we're looking at a couple different methods of taking what we have as our waste, which is mainly silicon carbide, and reintroducing it into the supply chain too.
Oh, very interesting. Do you have to smelt that in some way to make it useful?
Yeah, there's a few. What we're trying to do is we're trying to work with some partners who are in the silicon carbide market, who to make silicon carbide, you have to generate large heat to get them to fuse the carbide and the silica. So that same method could be used to clean the impurities into from our product.
I see. Okay, well that's very interesting. So you have now you've scaled up from a pilot project to a full scale operation. What were the challenges you faced in scaling up your lab tests into a full scale operation?
Yeah, so that's the part where we always say that's the hardest part. That's the hardest part of any technology, is moving from small scale to large scale. Mm-hmm. Where we're doing is a one of a kind, first of its kind. So you don't know what you don't know until you've done it.
So nobody else is doing this?
No, there's a few other groups that are still in the lab scale and who are in the news about doing that, but we're the first to have actually gotten it to a commercial scale.
Wow. Okay. Very good.
But that's a lot of learnings as you go along, because one example I like to give is pumping. And pumping is a notorious issue. And that's generally with just movement of material. And when you're small, and when you're in small scale, any of your pumps or movement of materials are always in excess of what your scale is. And everything works with brute force, because you can't usually get a pump small enough to be what your scale is.
Okay.
So when you go from something like an aquarium size pump with that little tube, mm-hmm. when you try to go it to being a 6-inch round pipe, 4-inch round pipe, the pumping mechanisms are always different, and it doesn't matter whatever curves and things you look at. Your material you can never completely say what your material is going to be like to the people who are giving you that those pumping curves.
I see.
It's all about a trial and error, and you can't pre-do it, because your brute force will fix anything in small scale, like I was saying. So that's a lot of the learnings where how do you upscale and take what information you get from outside sources, experts, that sort of thing, but they don't know, because what you're doing is first of a kind. That's where the hardest parts have been for us to move forward with.
All right, so you've got this proven now at industrial scale, and you're starting to do. Have you started processing commercially then? Or?
So we started, and then we got hit with Hurricane Helene. So then we were shut down, and then we made the decision, because we were shut down, we were going to relocate to a better facility. So we just relocated. So we moved from Greeneville. Now we're into just down the road in Newport, Tennessee. And so we're just restarting our operations. But we were up and running. We were processing material, generating revenue, and we now have a better facility from what we did in the learnings of the first time through.
Okay, very good. So you've got this first of a kind thing, and the silicon carbide. What's the source term for this mine? How do you get your catalytic converters? I mean, obviously your strategic relationship with Davis Recycling must be part of this. do you have a pathway to get catalytic converters and supply your plant?
Yeah, so there's a couple different paths we're looking at. One is your traditional scrap market. So most of this product comes from end-of-life scrap cars. And you incentivize the scrap dealers to take it off a vehicle before they crush them. And so they take it off, and then you purchase it through that scrap supply. So we're working on some relationships with the smelters. Like I said, how smelters don't want to process this, but they get material in from their supply, and they are looking for a diversion path so that they can accept all this supply and get the end metal that they want, but don't have to process it through their system. So those are a couple of the different pieces. And then on circular side, we're working with OEMs, equipment manufacturers, to add us to their circular. And if people know some of the auto industry type thing, a lot of the garages have core charges where they get to send back the old piece as a discount on the new piece. So what we'd work with the manufacturers is that adding this to their core program, which then they can come back, put it through us, process it, and then get the raw materials back to be able to manufacture again what they originally did.
Okay. Are there stores of these things that have been discarded that you're looking to go after in like waste dumps or anything like that?
There's some. I mean, most of it, it's once it's been mixed in, it's hard to separate out. But there's, in the US alone, there's 12 million vehicles scrapped every year. Worldwide, there's 27 million.
Wow.
So there's a bunch of fresh supply that keeps coming through.
And so what fraction of the market do you hope to be able to service with your production facility?
Well, our first line is going to be about 4,000 pounds of raw feedstock a day. So it's a tiny fraction. We'll look to scale up. And it's a lot there. Sort of said how 12 million is scrapped. There's only about 30% that's currently recycled. So,
wow. Okay, that's a significant impact.
Yes.
So
another statistic for you, just another quick statistic for you. So I talked about why the diesel is becoming a more niche, is that the walk through a little bit of the legal side, the regulation side. Catalytic converters started on gasoline engines, your automobiles. Equipment and trucks and that were not in the first set of that. But as time's gone along, the regulations have gotten more stringent, and they've been then sort of added it to diesel. So that means that there's a lot more diesels now coming to end of life that have catalytic converters.
Okay.
About 5 years ago, about 9% of the total catalytic scrap was SIC diesel. That is about 30% now.
Okay. Interesting. So, you know,
and heavy
the circular economy is kind of part of your vision. What changes do you think are necessary across the broader mining and recycling sectors that we could make this the norm rather than the exception?
So, way I look at this, and it's an overreaching type term, is urban mining. And so we're just a cog in the urban mining piece. And there is not enough resources in the ground to continue our lifestyle. We have to look at alternative processes. Mining is a key cog to be able to regenerate metals. And that's also where we like to look at is we're not just recyclers, we're regenerators. Because unlike some recycling, where the product keeps downgrading, every time we work in most of the urban mining environments, we regenerate the product right back to the original quality. And so it's exactly the same as it would have been coming out of the ground. it can be infinitely reused because you keep returning it to the original.
And you said that
urban
the environmental footprint of your process is much lower than the actual original mining.
Yes, tremendously. I mean, technically, we don't have a footprint. I mean, we're doing our process in a warehouse facility, so we're not disturbing any more land. We're just we're in the urban environment itself where the products are, regenerating them.
Well, you're using some energy, but
yes. So really a footprint of not disturbing land type thing. But yes, but we're very limited amount of energy as a comparison to the two other sources. I mean, smelting is a large amount of energy, and mining is also a tremendous amount of energy.
Yeah, a similar issue, I guess, I think is going to be felt in if you look at the energy transition to renewables, especially with solar panels coming to the end of life. The large push for the last decade of building new solar panels and trying to get the costs down. These things have maybe a 20-year lifetime. They're all going to be dead.
More meaning
and I don't know if there's anyone like your company that's.
There are a few. There are a few that I've heard of that are actively looking at that marketplace.
Mm-hmm. Are you looking at any other markets? Or are you focused on catalytic converters?
Well, we're focused at catalytic converters at this moment. We're open to looking at others, but again, we're small, so we have to walk before we run.
Mm-hmm.
To perfect this, generate this, be profitable and running, and then the world's our oyster. We can do all kinds of different things.
Okay, so the outlook is good now that you've moved. You've got a more efficient facility, and no new hurricanes on the horizon. Hopefully, what's your long-term vision for Regenx?
So Regenx is in the short term. We're going to become profitable and have ourselves running efficiently in our current operation. Then we look at expansion locally. We feel we can scale up to 4 times our current size at our current location.
Mm-hmm.
Then we look at saying, okay, how do we move this? Another site in the U.S., more opportunities globally.
Mm-hmm.
Large potential for where we could head on this.
Are there any environmental regulations that require recycling of catalytic converters, or is it just done on a pure profit basis?
It's done on a pure profit basis at this point. There is some things that are in the air of that a lot of governments have nominated PGMs, platinum, palladium, and silicon carbide as critical materials.
Mm-hmm.
So once you're on a list like that, worlds sometimes change, because especially in the US, who is looking that they want to secure their supply chain, and and most of the platinum and palladium that they use is imported, especially from South Africa and Russia. So if there's a local source, domestic source that could be tapped into, which is what we're providing, then different world conditions become part of the conversation.
Do you hope to influence policy at the regulations level to help with the market?
We do. We're a small fish, but we talk with different groups and that to try to push. There's a few groups that are focused in on precious metals, and so looking at how they can influence the conversation. That group has actually has been fairly successful on other pieces. I mean, the one part we used to hear a lot on was, "Oh, so you're part of the groups that keep stealing that stuff." Because in the news for a long time,
a lot of theft of catalytic converters. Yes,
yeah. So
I've heard of that.
Worked with governments and has set up some programs of things called Know Your Customer, KYC, And so you have to be able to show chain of custody throughout the process to be able to sell these things up and down the supply chain. So, I mean, our company ourselves, we had to turn back a group that we were going to purchase because they couldn't provide the proper provenance for what they were selling. So it's an example of how the group worked with the regulations to look at things that are affecting the industry. And so that same group will look at saying, how can they move in the future to be more beneficial?
Oh, very interesting. Well, I appreciate you coming on the show and sharing your work with us and Regenx's success at getting to this stage. I think it's a great environmental success story. The way you can, mitigate the need for new mining, I think is something we all have to look at if we want to be, manufacturing more cars, manufacturing more solar panels, manufacturing anything which has these precious metals or rare earths, things that are very rare and difficult to find. This is key process that needs to be there to, I think, support these things. So kudos on getting here, and thanks for talking to us today.
No, my pleasure. Always enjoy being able to tell our story.
Okay. Bye-bye.
If you'd like to follow up with more in-depth discussions, please come find us on Facebook at The Rational View and join our discussion group. If you like what you're hearing, please consider visiting my Patreon page at patron.podbean.com/therationalview. Thanks for listening.